This example is more like something that you would see on a test or a quiz. This example says express in terms of sum and differences of logarithms, and then expand it completely. You're going to have to use these three rules to start your problem. And the most important thing is knowing which rule to use to start. What I tell my students is to look at the big picture of the log. There are going to be smaller bits and pieces that you want to ignore to begin with, but you want to look at the log as a whole and decide which of the rules, product, power, or quotient, does it most fit at the beginning of the problem. This particular problem, I see bits and pieces that have powers on them, but the entire argument is not raised to a power, so the power rule is out. I also see bits and pieces that are multiplied together, but the entire argument is not multiplied, and so the product rule is out. I go to the quotient rule, and the quotient rule says I'm taking the log of the quotient of two values, and that's the thing that fits the most. We see here we have a fraction, we have a top, and we have a bottom. It doesn't matter how many pieces are in that top and bottom. So the first thing we're going to use is we're going to use the quotient rule, and I'm going to go ahead and write that to begin with on this example so that we can follow and know exactly which rule that we're using. The quotient rule says that you want to take the log of the top minus the log of the bottom. Make sure that you're keeping the base the same. So this would say keep log base b, and then you want to take as the argument the top, and then you're going to subtract off log base b of the bottom, m to the third, b to the seventh. Okay, now, anytime I use a quotient rule, it's a good idea if you put a bracket or a parenthesis following where you have your subtraction symbol. And the reason being is that if there's more to do, that subtraction symbol will end up having to be distributed to more than one term possibly. So anytime I use a quotient rule, whether I need it or not, I'll always put a bracket after my minus sign. Once we've done this, now we need to decide what other rule to use. Okay, well, I see powers, but I don't see the entire argument having a single power. I see separate powers. So the power rule is out. Okay, I see products, and these two different pieces are both products. So we're taking a product here and a product there. So I'm going to use the product rule twice. So I'm going to put product rule here and product rule here. Okay, doing that is going to, I'm going to say create a longer looking expression. Okay, so here I'll have log base b. Product rule says when I'm taking the log of a product, it splits apart as the sum of two logs. And so here it would be log base b of p squared plus log base b of q to the seventh. Now in my expression I then had a minus sign and then I had a bracket. I'm going to keep that. And then on the second log I would have log base b of the first piece of my product, which is m to the third, and then plus log base b of the second part, which is b to the seventh, and then end my bracket. So I've taken both the two logs that I originally had that were both products and used that product rule to split them apart. Now I look at what my arguments are, and I notice that all my arguments have powers on them. So I'm going to use the power rule. Power rule says whatever the power is on your argument, you're going to multiply that to the front of that particular log. And so here, this would become 2 times log base b of p. This would become plus 7 log base b of q. And then minus, I'm going to keep the bracket still. This would become 3 times log base b of m plus 7 times log base b of b. And then close bracket. Now, the instructions said express as a sum or difference of logarithms. I've done that, but then it says expand completely. Okay, this is where I need to know, am I done or do I need to continue on? One thing that I for sure need to do is I need to take this negative and I need to distribute it in front of those two terms. Another thing I need to do is go through and look at all my arguments and see if there's a rule that I can use to reduce some of them. First one, I have log base b of p. There's no reduction. Next one, log base b of q. No reduction. Log base b of m. No reduction. But then when I get to the last one, I see log base b of b. The important thing to notice there is that this b matches the argument, and then the understood exponent on the argument is a 1. And so that entire log part would reduce to a 1. And then you have that 7 multiplied in front, so it would be a 7 times a 1. So I'm going to do two things on this next step. I'm going to distribute the negative, and then I'm going to simplify that last log, and I should be done. So 2 log base b of p plus 7 log base b of q minus 3 log base b of m. Distributing the negative, this would become negative 7 and then times 1. Okay, and then I'm actually going to go back and I'm going to erase the 1. 7 times 1 is just 7. What I'll do to kind of help you remember to note that we've done that is that this whole thing equals to 1, so it can be reduced out. Okay, this would be your final answer. These problems take a lot of practice. You got to make sure that you actually know your rules. I'm going to say know them by memory without having to refer back to them. The other thing is that these kind of problems can actually be done in fewer steps. So once you get the hang of problems like these, sometimes it's helpful to do it in fewer steps. And if that's the case, then I don't have a problem with that. If you need as many steps as I have shown, then that's okay with me as well. As long as you get the answer that I get at the end and that you've done everything mathematically correct, then I don't mind how many steps you use to get your answer.